So this is the fourth video covering activity 1.1. We're going to begin on page 8 in the handout. Everything we've done up until this point has always been a straight line. All the lines we've drawn have always been straight, whether they go up from left to right or decrease from left to right or just are flat horizontal. Now we're going to examine lines that are not linear. They're going to have a little bit of a curve to it. So take a moment just to read this paragraph here. You notice how it says Marty jogs very slowly at first and then faster and faster? If it said Marty jogged at a constant rate, we'd have a straight line. But slowly at first, that's this area. And then the faster and faster is the steeper part, okay? And then they take a moment to let us know Marty is not running at a constant rate, so the graph will not be linear. Okay, so if I look at problem 4, it says draw a graph for this story. Marty jogs around the track very quickly at first, then runs slower and slower. So I'm thinking here is the quickly at first and then the slower and slower, and we'll kind of taper off. Let me try and draw that again because that is a little sloppy. Okay, here's take 2. Quickly at first and then slow. So here is the quickly at first, and then this part is slow, okay? Part B. Okay, so now it says we have a hot cup of coffee, and this graph describes what's happening to the temperature as time increases. So if you think about it, temperature of coffee should be very hot, right? That's a value up here, right? The temperature is very high. Then eventually the temperature is going to cool as the cup of coffee cools to, let's call this maybe room temperature, right? I don't know, maybe this is 70 degrees. I don't know how hot it is in your house, but right, the temperature of the coffee will not fall below room temperature, right? So if your house is 70 degrees, the coffee will fall to 70 degrees. So initially, you take your coffee out of the K-cup machine or whatever you have to make coffee. It starts out hot, it loses temperature pretty quickly, and then slowly approaches room temperature. So here's my little blurb, right? The coffee starts out hot, quickly loses temperature until it slowly approaches room temperature. In the second section of this activity 1.4, we start to talk about functions, okay? We discussed how the input is typically, or really, the input is always found on the horizontal axis and the output is always found on the vertical axis. And the relationship between the input and the output really it's a special relationship, and it's really describes the definition of a function. So this definition is very important. I don't typically ask the class to memorize definitions, but this is a definition that you really should commit to memory. Okay, so a function is a correspondence between an input variable and an output variable. Is a function if each value has exactly one output value, right? So for each input, there's exactly one output. All right, so this one again, I would maybe pause the video and take a minute to just really read this and think about this, right? For each input, there's exactly one output. If that's the case, we have a function. So we go to example 1, we start thinking about Marty running around the track. So Marty's total distance depends on the amount of time he's been running. Okay, so the time would be the input and the distance would be the output. Right, so since output depends on input, we know from this statement that the amount of time is the input and Marty's distance is the output. Right, I did a quick makeshift sloppy graph here. Right, time is on the horizontal axis, and input is always on the horizontal axis. Vertical axis is distance, and the output is always going to be found on the vertical axis, okay? So then we're saying, all right, let's assign variables to the input and output, which I've done, right? I used t and d. And we can maybe express this using function notation, okay? So when I'm thinking about function notation, right, you see we have d is a function of t, right? So distance is a function of time. So let's think about this. Distance, right, d. As soon as I see the word is, I know that's always equals. And then whenever you see the word function, think of that as f of open parentheses. And then whatever comes after the word function of goes inside the parentheses. Right? So this is considered function notation. And then you see down here, they've just written it nicely for us, right? D is a function of t. Distance is a function of time. So just remember the word is will always be the equal sign, right? Distance we call d. Function we call f of parentheses, right? F and then open parentheses, and whatever comes after the word function of always goes inside the parentheses. And that's function notation. I'm surely going to ask you to do something like this on a quiz and a test, okay? They talk about how to read that, right? D is a function of t, all right? So don't think of this as f times t. There's no multiplication symbol here, okay? And then another thing to think about is, I wrote it as d equals f of t, but this is perfectly acceptable as well. Let me turn that on. So if I wrote f of t equals d, remember this is the same, right? These two are saying the same thing, so the order doesn't matter, okay? But what's important to note, whatever in the parentheses is always going to be your input variable. So if I were to say, looking at these two, which is your input? Well, whatever's in the parentheses, right? So the t is in your parentheses, so the t would be your input. Okay, and whatever's on the outside of the equal sign, or the other side of the equal sign, is your output. So in this case, my D would be my output. Okay, so again, take a moment to digest that, right? They give us an example 2a, so there's no work to do here. They've done the work for us. So it says, suppose that Marty's time is given in hours. Let's think that Marty runs at a constant rate of 6 miles per hour. So if Marty runs 1 hour, his distance would be 6 miles. So if the input is 1, that's 1 hour, the output is 6, right? So the function notation would look something like this, right? Where that's the D, which is he ran 6 miles, and the input was the time, which is 1 hour, right? So if he ran for 1 hour, then he ran 6 miles. Example 2b. All right, same logic, right? So now I'm looking at this 3 and the 1/2. So if you think about it, if he ran for 1/2 of an hour, how far did he run? 3 miles. Okay. So that's us interpreting function notation, right? I kind of like these two exercises. Maybe you should put a little star next to these, because I think I'm going to want to come back to these in the future, right? Again, maybe on a test or a quiz. When I look at problem 2, it says, okay, interpret the practical meaning. I also ask these types of questions a lot. Interpret means write down in words what you think is happening. So you see the 2, we know that's the input or time, and that's the distance. So I'm thinking if Marty ran for 2 hours, then he ran 12 miles. All right, so I like to write if-then statements. If whatever's in the parentheses, then whatever's on the other side of the equal sign. So in this case, if Marty ran for 2 hours, then Marty ran for 12 miles. And that's it. That's us interpreting the practical meaning of this. Right? Problem 6. From the graph, let's fill in the blanks. So remember, this is our coffee problem. Right, so time in minutes is the input, right? So time in minutes is the input because it's labeled on the horizontal axis. And again, the horizontal axis is always the input, 100% of the time. And the output is always on the vertical axis, right? So the temperature of the coffee is the output because it's labeled on the vertical axis. And then the last part, part B, let variable t represent the time in minutes and the variable c represent the temperature in coffee. And here we go in terms of function notation. Right, so temperature of coffee. So we're going to use C for the temperature. Right, C represents the temp. So C, there's temperature. I see the word is, I know that's equals. I see the word function of, so that's F and open parentheses. And whatever comes after function of goes in the parentheses. In this case is T. That's our function notation. So I think we'll stop here and we'll do one more video to finish up this packet.